Hello Math 1093, this is Dr. P with a video on what is radian measure. So you may have heard of the idea of radian measure before, and you may remember from high school or someplace else that pi radians are equivalent to 180 degrees. You may have heard of that. In this video, I want to talk about a way of thinking about radian measure that is completely free of degrees. It's completely independent of degrees. And that is to start by thinking about the idea of the radius of a circle. So I've drawn a circle here, and I'm going to sketch the radius, or a radius. There are many radii. Okay, we're going to think of this radius as being its own unit of measure, which I'm going to call 1 radius length, because that is the length of 1 radius. That is 1 radius length. Okay, so now I'm going to explain what a radian is without even mentioning degrees again. Now remember that a radian, that is a unit of angle measure. So probably the best way for me to tell you what a radian is to actually construct an angle whose measure is 1 radian. So here's how you do it. I'm going to start here on the rightmost point of this circle here, and I'm going to start traveling around the circle until I feel I have traveled a total of 1 radius length. Okay, so keep an eye on the radius length and think about when I should stop. I should stop when I've traveled 1 radius length worth of distance along the circle. I'm going to stop somewhere around here. That looks like the total distance I've traveled. Now, really, I'm traveling along the circle. I just wanted to mark so it was so you could see it clearly. So I've traveled along the circle, and the distance I've traveled is 1 radius length. Okay. Now I haven't constructed an angle yet, so here's how you make the angle. I take that point and I connect it to the center with another radius. And then the angle that I've swept out, let's call that theta. That is an angle whose measure is 1 radian. So just to summarize, 1 radian is the measure of an angle, that subtends an arc whose length is 1 radius length. That's what 1 radian is. Okay, but that's not just true of 1, that's true of any number. So I could also say that theta radians is the measure of an angle that subtends an arc whose length is theta radius lengths, assuming that theta is a number. So this is for any number theta. All right, so for example, let's suppose I sketch some other angle here. Actually, I'm going to create another circle in this picture. So I'm going to drop down here and then add another circle to my picture. There we go. Okay, you should see it now, hopefully. Let's suppose I draw some angle here. Let's say this much. I'm going to be bold here and pick this angle. Okay, let's call that theta, or let's call the measure of that theta. Usually we use theta to represent the measure of an angle, not the angle itself. Okay, what would be the approximate measure of this angle in radians? Well, I can count off radius lengths along this arc. So I go here, this is 1, and then this would be about 2, I think. I'm really guesstimating here. This would be about 3. I'm not quite at the equator yet. And then this would be not quite a 4th one. This would be somewhere around 3.6, 3.7 radians. But you'll notice I measured that angle. I'm going to say about 3.6 radians. I measured that by counting how many radius lengths I went around. By the way, why is it that 3 radians was just short of this point here? You remember that the circumference of a circle is 2 pi r. That is, the circumference is 2 pi radius lengths. That's literally what that formula means, is the circumference is 2 pi radius lengths. So if I go halfway around the circle, I should have done half of that. Halfway around the circle, that is equal to pi radius lengths. And that, by the way, is why it is the case that 180 degrees, that is half of the circle, is equal to pi radians. All right. In the next video, we're going to talk about how to apply this idea of radians to talk about linear and angular velocity. So stay tuned.